So we were interested in being able to move between these different forms of quadratics. So we said to go from vertex form to standard form, we expanded. To go from standard form to intercept form, we factor. To go from intercept form back to standard form, we FOIL. To go from standard form to vertex form, we're going to do something called completing the square. I'm going to abbreviate that as CTS. And this is what we're going to talk about today. This process is not real easy. It's a little bit complicated. It's going to inherently often involve fractions. I know. So I'm just telling you that if you have an A game, if you can manage to muster that up the last hour of the day on a Thursday, you want to do your best to muster up your best attentive A game. I'm going to try to go slow. If I'm doing something you don't understand, please stop and ask a question. This is an important process. I do expect that you're able to do this. It's not going to be easy the first time through. It will get better. But this is what we're going to be talking about today, is this completing the square process. That's what I mean by CTS. Yes, Elena. Yeah, that's fine. Sure. Connor, you got to start shrinking. Bring a phone book for you to sit on tomorrow. You can bring a phone book to sit on tomorrow. So the key or the motivation behind doing this is this formula that we talked about last time. You remember this formula that I gave you guys and said it was going to be important later on? This is when it's going to become important. And it's really important because it's our motivation for how this completing the square process is going to work. So I'm going to just kind of start with an example. So let's say we have just a standard form piece like y equals x squared plus 4x plus 9. We're trying to rewrite this standard form as a vertex form. That should look like this. That's our goal, is to turn that standard form equation into a vertex form equation. So the way we're going to get this part here is going to be using this identity up above. So you see the x minus h squared part. We're going to use that identity above to do that factoring, basically, is what we're doing now. Okay. So, the first step that I want to do is I want to make the leading coefficient 1. When I say leading coefficient, what are we really talking about here? It's the number in front of the x squared. Well, in this case, it's already 1, so we don't have to do anything for this particular example. In a moment, we'll do an example where that's not the case and things get really gross and fractiony, but I don't want that to be our first example. Okay? So we're good on that first step. Let's do this. The next thing we're going to do is subtract c from both sides. What do I mean by c? I mean in a standard form equation, we're talking about the coefficients a, b, and c. You know what? One moment here. Before we get going too far, rather than calling these a's and b's, because I'm going to start referring to this in a minute, we have a's and b's in our standard form equation. I have a's and b's in this. That's going to get really confusing, right? Let's call this y's and z's. We don't have any y's and z's running around here. That'll just make life a little bit less confusing, I think, for everybody. To not use the variables for two, like the same variable name, for two separate things. You guys get what I mean there? So that was going to get confusing, I think, real quick. So I'm going to just change those to like y's and z's. It didn't matter what the letters were. I just didn't want to use A, B, or C. I didn't want to use X because we already have those when we talk about the standard form. So I just picked something that we haven't really used. I guess we have Y's floating around there too. That's a bad decision there too, huh? Here we go. We'll use U and V. That'll be even better. I know. Isn't that just the worst? All right. So I'll do U's and V's. We don't have any U's and V's. We haven't used U and V for anything yet, right? Sorry about that. I'm just trying to make it so it's like it gets less confusing later on. I put a tail on my U's and I have no tail on my V. It'll be okay. I know, Josie. There's no good letter combinations left for me to pick. We used M and N's, H and K's already used. You know, like I's and J's both kind of look the same. Like there's not a lot of combinations left here. We have F for function, you know, like, well, you want me to use R and S? Well, S's look like my 5s, you know, like we can keep going and make excuses. I have to use something here. I'm going to use U and V. All right. Okay, so when I subtract C from both sides, I'd get Y minus 9. So when we talk about this equation, this is a standard form equation. So I'm talking about, when I refer to the standard form equation, I'm talking about A, B, and C from the standard form equation. So when I say the leading coefficient, that's A. When I say C, that's the C here. Okay, so this is the tricky part now. We haven't done anything that's terribly difficult, right? We just moved the 9 over to the other side. Is I want to make this x squared plus 4x into something in the form u squared plus 2uv plus v squared. Okay with that? So in this case, I'm just going to write some hypotheticals down here. Basically, my u and my x can be the same thing, right? Everybody agree with that? My v, well, let's do this. What color do I have? Yellow. So my 4x then is going to be the same as my 2uv. Everybody agree with that? So what does that tell me? Well, if I know that let's say 2uv is equal to 4x, and I know u is x, if I divide both sides by 2x, I get that v is 2. So I said this piece is going to be the same as this piece, right? That's all I'm doing, so that's what I've written here. Is that okay? What I then did is, since I know u is equal to x, I replaced my u with an x. And then to get the v by itself, I divided both sides by 2x, and I have that just v is 2. Is that okay there, Jordan? You were the one that was like, hey, wait, what did you do? Does that clear that up at all? So u is the same thing as x, right? We wrote that here. So where I had a u, I've just replaced it with an x. Grace, was that your same question? Okay, what's your question? Okay, no problem. Okay. So what I want to do then is I need to now add v squared to both sides. Because I know what v is, I can do that. Now the way I'm going to write that is a little bit different. I'm going to say add b over 2 squared to both sides. And what b am I talking about here? I'm talking about that b from our standard form equation. So this b over 2 squared is the same thing as a v squared, right? So in our case, I'm going to write it this way just so that when you're looking at your notes, it's a little bit more clear where this came from. I know that's a silly way to write it, but if you're going back to look at your notes and we just put a 4 there, you're going to be real confused at where the 4 came from. If I write this as 4 divided by 2 squared and you look at the instructions on the side, it'll be a little bit more clear where that 4 over 2 squared is coming. So what we have here is we have v squared now plus 2uv plus v squared. That is now in that proper form, so I can factor it. How can I factor that? I know that this is equal to u plus v squared. In our case, u is x and v is 2. Now if I go to the left-hand side there, 4 minus 2, or 4 divided by 2 is 2, and 2 squared is 4. And if I add that 4 and negative 9 together, I get negative 5. And if I add the 5 over, I have vertex form. So that last step would be then just getting the y by itself again. Possible? Sure. You could bring some extras back with you so you don't have to keep going. I know it's a hassle. You always seem so frustrated by life. Yeah. Seems like he's suffering a bit with this cold that's been hanging around for a while now. Oh, I'm sorry. Where to? Okay. That's okay. So we're going to do another example similar to this one, where the leading coefficient is still 1, but maybe some fractions kind of creep into the problem. Okay with that? And then we'll do another example where the leading coefficient isn't 1. Okay with that? And that'll probably be 3 examples, is probably as much as it's going to make a difference for today. You'll need some time to practice some things on your own and that stuff. Depending on how much time is left, we might do some more factoring practice or something to kind of finish the day out. Okay? Josie, are we good? You're welcome. So let's say we have the standard form equation, y equals x squared plus 7x minus 3. So what I'm going to do first is I'm going to add the 3 to both sides. Because my leading coefficient was already 1, right? Everybody so far so good? So I started by adding 3 to both sides because my leading coefficient was already 1. Now what I'm going to do is I'm going to add b over 2 squared to both sides. In our case, b over 2 squared is 7 over 2 squared. So now I'm going to factor this. how does this factor? Okay. The way this factors, if I scroll up, is using this formula. It's going to factor like this. Okay. So my u is just x, and my v is b over 2. You don't really need to think about it. You don't need to double check it. You don't need to try to find two things that multiplies to give you and adds to give you. Like, it makes life pretty crummy to try to do that. Just use that factoring pattern that we established at the very beginning that was like our key to being able to do this. Grace, you have a question? Why isn't it? It's not. Okay. So before, when we did this one, we picked the u to be the same as the x. So there's my u, right? That's why I'm getting the x. And then the v that's going to go here with it, how did we get the v? We took that middle term and divided it by 2. So it's always going to be that b over 2. It's always going to be that. You're good now, though? Or no? Okay. So we're here, is where we're ended at. The last thing we need to do is take care of this side now. So we just need to add some fractions and then move everything onto the other side. So to add 3 and 49 over 4, what do we need to have? Common denominator. What would that common denominator be? 4. So how do I rewrite 3 with a denominator of 4? 12 over 4. So if I add 49 over 4 and 12 over 4, I get 61 over 4. And then I can just subtract that over to the other side. Now do you see why, when we talked about graphing, why I didn't want to just put everything into vertex form and do the graphing all the same way? Because this process here of getting things into vertex form isn't particularly fun, right? This is pretty time-consuming and rather detailed. Much easier to do the graphing the way that we had described in the graphing homework by just finding the vertex and then picking some points on the other side and plugging stuff in, right? Let's do one more of these. This time I'm going to add in a leading coefficient that's not 1. Actually, let's be bad. Let's make that a 7. Make this as fractiony as I can. The first example didn't have any fractions. So the first thing we want to do is make the leading coefficient 1. How am I going to turn 2x squared into 1x squared? I'm going to divide both sides by 2, right? So divide both sides of the equation by 2. Division is distributive, though, correct? Everybody agree with that? So I get 2x squared over 2, which reduces down to just x squared. I'd have minus 5 over 2x, and then I'd have plus 7 over 2. Okay to hear? It's just some fractions. It's okay, guys. What I'm going to do next is I'm going to subtract that c from both sides. So I'm going to subtract 7 over 2 from both sides. Yes, Chris. It's probably a bad idea. Okay. What comes next? So I got the leading coefficient to be 1. I move the c onto the other side. I add b over 2 squared to both sides. So my b is negative 5 over 2. Right? This is my b. What is b over 2 then? Negative 5 over 4. Why is that? 5 over 2 divided by 2 is the same as 5 over 2 times the reciprocal. Do we remember that from, I don't know, middle or elementary school? Dividing fractions. What I remember from that time was dividing fractions as easy as pi. Flip the right and multiply. Just like a little rhyme to help me remember. So you flip the one on the right and multiply. Anyways, so I'm going to add, but I'm going to write it this way on this side. Now, this part is lovely because it factors. Yes, I wrote one as negative 5 over 4 and the other one as negative 5 over 2 over 2. They're the same thing. I'll explain to you in just a moment why I chose to write them that way. I know you're giving me some dirty looks. That's okay. It is scary. There's just a lot of fractions going on, but it's not that big of a deal. They're just fractions. They're just numbers. It's all just numbers. It's okay. They're your friends. They are. They've never done anything to you. All you do is badmouth them all the time, and the fraction just sits there and takes it. Okay. So, this right-hand side is going to factor. How is it going to factor? Just like that. Now you see why I wrote that one side as negative 5 over 2 over 2 rather than negative 5 over 2 over 4, so that it would be easy to see how it was going to factor. On the left-hand side now, I'm just going to do a little bit of simplifying. So when I take negative 5 over 4 squared, to square a fraction, I square the top and I square the bottom, right? So negative 5 squared is positive 25, and 16 squared, or 4 squared, is 16. Okay with that. If I look at the left-hand side now, all I have to do is kind of clean things up over there. So we need to combine the negative 7 over 2 and the positive 25 over 16, right? To add those two fractions, what do I need to have? Common denominator. What would the common denominator be for 7 over 2 and 25 over 16? 16. What would the common denominator need to be for 7 over 2 and 25 over 16? It's 16, right? So what do I have to do to the 7 over 2? Multiply it by 8 over 8. 8 times 7 is 56. 2 times 8 is 16. So when I finish adding those two fractions, I get minus 31 over 16. I'm going to add 31 over 16 to both sides. I'm now trying to get that y by itself. And the last thing I need to do is to multiply both sides by 2 to get rid of the y over 2. So when I multiply that 2, that's going to distribute. What is 2 times 31 over 16? 31 over 8. Remember that to multiply fractions, we can reduce as we multiply, like that. That's 2 times. Should I do the dot? Okay. No, that's fine. Fair question. That's why, again, I encourage you guys during the course of this. Please ask.